Cool. Welcome to the Smooth Brain Society. With me, our guest today, our researcher today, is Dr. Marina Wimmer, who is an associate professor in the School of Applied Science in Edinburgh Napier University. She is an expert in cognition with a particular focus on visual ambiguities and false memories, and essentially how we see environments. So, C's in quotes, how we see environments in our minds without any actual stimuli being presented. So she currently leads the Center for Mind and Creativity Research, which uses vision to examine cognition in a fast-changing world and to use knowledge from cognition in the building of our environment. Um, she has a lot of her studies cited on Wikipedia pages about visual ambiguities as well, if people want to look that up. But welcome to the podcast, Marina Weber.
Thank you, Sahia, for having me.
And our other guest today, or my co host today, is Simone. I'll let her introduce herself.
Hi, I'm Simone. I am a media and psychology student in Victoria University. I'm a first year, so a little bit of a yikes, but closer to the end, so I like to think of myself as an honorary second year at this point.
That's that's awesome. So Marina, we spoke about this off before recording, but just to reiterate, the way it works is we will basically go through a little bit about your research, and hopefully we will ask questions which will help us understand your field. So we'll keep just conversing back and forth about your research. So with that in mind, would you like to start off with telling us a little bit about how you got into this field in the first place? Uh,
So that's quite a convoluted story, so I try to be very short. I worked during my undergraduate studies as a research assistant for a professor that was super interesting, and he used methods like thinking out loud and following people around and observations. So I got a keen interest in research then during my undergraduate studies at Salzburg University. And part of our degree was a requirement to do an internship. And the job market was tough at the time. So the more internships you did, the better your job opportunities. And one of the internships was advertised as going abroad, either to Stirling University or to, I think it was Sussex University. So I contacted our professor, who was our contact person, and he basically put me in touch with contact people in Stirling and in Sussex University. And I ended up going to Stirling University to do an internship for a month. And I worked with Dr. Martin Doherty, who then used to be at Stirling University. He's now a reader at University of East Anglia. And he did a lot of work on theory of mind, on how children develop an understanding of other people's mental states and beliefs and emotions. And he basically showed me these ambiguous figures. And so, for example, the famous duck rabbit figure, and said there's something interesting with those figures because you have one stimulus that can have two interpretations. And he did a lot of work on this children's developing understanding that one thing can be two different things, which develops between the ages of 3 and 5. So, for example, the word bunny and rabbit can refer to the same thing, or that a bat can be a flying mammal in one situation or piece of sports equipment. And he said, well, ambiguous figures are something similar. You have one stimulus that can be two different things. So I wonder whether there is some relation in the development. And so we started to investigate this. And so we looked at which age do children understand that this figure can be two different things. And what is interesting is that by around the age of 4, children have no problem to understand this can be a duck or this can be a rabbit, but they don't see both interpretations. So they conceptually understand visual ambiguity, but they can't perceive it. And that's particularly interesting because the perceptual system is developed. So they should have the perceptual requisites to see both, but they just can't. And so that formed the basis then for my PhD, is like what needs to develop, what are the specific cognitive processes that allow us to see the two interpretations. And the developmental approach is great because you have an age group where they can't see both and an age group where they can. So you can look at what abilities do need to develop that allows us to see both. So children as participants are fantastic because you have age groups where someone can and someone can't do something at a certain age. And it allows you to look at the specific processes involved, which you can't do with adults. So that's how I got into researching ambiguous figures perception.
That's a pretty interesting story.
Yeah.
I
was trying to make it quick. I could make it longer, but that is the quick.
I mean, I'd listen to the longer version. That sounds like it was. That's really fascinating. The idea that, you know, there's a point, because I don't think I've ever seen one of those images and not been able to flip between the two, you know, visual things. So it's interesting to think that there was a point in my life where those systems in my brain weren't there, you know?
Mm-hmm. So I would suggest that if you look at some that are less famous, the duck rabbit is very famous. And I would suggest if you look at one that is less famous and you do not necessarily know that it's an ambiguous figure, you might not be able to flip because knowledge of the ambiguity is a key fundamental process that is a prerequisite that is important. And that ties in with the fact that we don't just see what is there in front of us, we interpret what we see. And the more we know about the world, the more it affects what we see. So, yeah, so I always do this with my students in my development of visual perception lecture. I show them an ambiguous figure that isn't well known and I ask them what do they see. And usually someone sees a cowboy and the other one sees a Native American or a witch. It's a bit difficult to identify the other interpretation. And then as I keep looking at it for 60 seconds, and the majority of them say they just see one thing. And then I tell them what the two interpretations are, and I point out the different features of each interpretation and say, look at it again for 60 seconds. And what you then find is that the majority is able to switch. So the knowledge of ambiguity is key. It's quite important in being able to perceive the two interpretations. So this tells us that our visual system is very influenced by what we know about the world. So it's not just what we have in front of us, the colors, the features, it's really what we know about the world. And what I found interesting is that children at 4 years, even they know what the two interpretations are, they just can't see it, they can't flip. So we've been looking at what develops between 4 and 5. By 5 years, the majority can flip and can see both interpretations. So we've been looking at what is it, what develops, what are the specific cognitive processes. And we found that there are two important processes. So one is inhibited control. So you have your prevalent percept. So when you look at the duck rabbit, you first see one interpretation that it's your prevalent percept. And say you say it's a duck, you think you see a duck first. That's your prevalent percept. So what you need to do is you need to inhibit your prevalent percept in order to then switch to see the rabbit. So it's inhibitory control that is crucial. And the other is mental imagery, so making a mental image of the two interpretations, particularly the non prevalent percept. So having a mental image. And those are some key cognitive processes that explain the ability to switch. So it's not a low level visual system development, because the majority of the visual system is developed by the end of the first year of life. And so the visual developments, the visual processes required for seeing ambiguity are developed by the end of the first year of life. But it's a cognitive process, and that's, I think, what is interesting. So I think having a developmental approach allows us to get more insight into the specific processes involved into something. And what we found is that this being able to see the two interpretations around the age of 5 is obviously for very simple stimuli. So we haven't tested complex stimuli. We haven't tested any, of these more difficult images. And I think that's a way forward to look at how the complexity of visual information affects what you see. But we haven't done that yet.
That's really cool. I think we should probably start off somewhat even more basic. Could you tell us, because you said higher and lower levels, what in visual perception and cognition, could you please break it down and explain what cognition is versus perception? Or, um,
Yeah, sorry. So, in perception, so the idea is that when you see something, so say you look outside of your window. So I'm sitting in Edinburgh at the moment, and my laptop is facing the window. So I see my street, and I see a tree that is green and leafy and things like that. But I obviously know that that's a tree. So I see the color, I see the shape, which are kind of low level visual features. And then I interpret what I see and say, oh, it's a tree, because I know how trees look like. So that's the difference between low level and high level perception, is where low level is just having some visual things in front of you, and you just see it without interpreting, without thinking about it. And high level is interpreting what you see. And so the more you know about the world, the more of this interpretation you can do. And also the more it's what you see is influenced by your knowledge. So that's knowing what you see, interpreting, that's higher level. And low level is just the visual information that's in front of you.
cool. So then going back to your study, you were talking about how from the age of 4 to the age of 5, you slowly see this change in being able to decipher between the duck and the rabbit and both interpretations. Do you think that if these images are shown a lot earlier, the a child is able to perceive them a lot faster? Because you said over time and experience, you learn how to uh, perceive higher level things. If you show stuff earlier, do they start perceiving them earlier?
Well, that's a great question. So I would say no, because conceptually, before the age of 4, children have a hard time understanding that one thing can be two different things at the same time. So, for example, if you show them a picture of a rabbit and you say, look, that's a rabbit, but it can also be a bunny. And they might just say, no, it's a rabbit. It's like, yeah, but it can also be a bunny. And they just will say, no, it's a rabbit. Uh, so they have a hard time before the age of 4 to understand the two perspectives on the same thing are possible, um, or for example, if you have um, the word bat, that can be two things, right? It could be a piece of sports equipment, which you know about in New Zealand could get, or it could be a flying mammal, and they have a hard time to acknowledge that at the even though they know what it is, so they can in one situation perfectly well interpret this as a bat, as a piece of sports equipment, and in another situation as a flying mammal. So that's not the issue. They're just having a hard time acknowledging that one thing can be one thing, or one word, or one photo can be two different things at the same time, and both are equally valid interpretations. And that's something conceptually that develops around the age of 4. And it's what we call meta representation. It's like this idea that one thing can have two different interpretations. And that is, you can see that in other domains. So, for example, in photographs where kids find it, they really young kids can say that this is a picture of an ice cream, or this is a picture of mommy or daddy, and yet they make these funny referential confusions where they say a picture of an ice cream can be cold, and we suggest these errors happen because they have difficulty to acknowledge that yes, this is a picture of an ice cream here and there and represents an ice cream in the real world, and the two are different ways. The two are different representations of the same thing. And so, long story short, to answer your question, I think even if you were to show kids much younger those ambiguous figures, they would not be able to switch because they conceptually are not able to understand that two things can be possible or can be seen on one stimulus. And so that needs to be the prerequisite. The prerequisite development is conceptual understanding of ambiguity, which develops around the age of 4 and is linked, as we call, to meta representational understanding. And once you have that, only then later on you're able to switch. But you need to develop inhibitory control and mental imagery that allows you then to see the two interpretations. So it's like a two-step process almost.
So, completely off topic question, probably, but this idea of being able to see two things in one image, is that kind of the same thing as like looking at clouds and seeing like this cloud looks like, or like looking in grains of wood and seeing figures and things? Is it kind of the same thing? Because I remember doing that as a kid quite a lot.
Yeah, in a sense, yes and no, I will say, because in this, say, cloud scenario, there isn't a correct or wrong answer, right? Because you could see as many different things. So it's using your imagination in seeing other things in things. But there isn't a clear cut, I'd say, yes and no, this can be, I don't know, this cloud looks like an aeroplane. Yeah. And another one might say, oh, it looks like a dinosaur. And it's sort of using your imagination to interpret what you see. This is evidence exactly of this higher level visual perceptual processes by which you start interpreting what you see. And that indeed, that you have early in childhood, and it's really cool to see when kids start interpreting what they see. So it's a good example of this higher level visual processes. I should have used that one when I described my tree.
So then the next question comes, how does this work in the brain? Why do we do this? Are there regions in the brain which cross over for why we perceive one but don't see the other, or why it takes time to switch? What are the reasons for it?
So that's tricky, and I'm not a neuroscientist, and I think the only way to properly answer that would be probably with TMS methods, where you transcranial magnetic stimulation, where you basically zap someone and make someone's area of a brain not functioning, and see how that affects your perception. Um, so basically, the simple answer is that the lower level visual area, so the occipital cortex, the bit at the back, um, that is that is basically all visual information. That's V1, what we call V1, goes through there, and that's just early perception. So that's the lower level, and then the more you think about what you see, the higher it goes into your brain, in the sense the frontal lobe, the front of the brain, that's the higher level um, cognitive areas is involved in. So there isn't a module or a specific area in the brain that allows you, and say you have a, there is some lesion studies, so where someone has a lesion or brain injuries in the frontal cortex, for example, finds it difficult to see the two interpretations. So there is some evidence, but these are usually based on a single participant, or you have, people who have brain injuries, have very specific localized brain injuries, so you can't really compare them to each other. So it's very difficult to say. I will say that for inhibitory control, so inhibiting your prevalent response, there is an area in the brain that seems to be specific to inhibitory control, and it's the dorsolateral prefrontal cortex. So that's quite a mouthful. So people who have injuries in that area would probably struggle to see the two interpretations. But again, there isn't a specific brain area, like a module that is associated with being able to see ambiguous figures, because it's, as I said before, it's like low level and high level visual processes that are involved. So low level being the occipital cortex, and high level being more the frontal area. So when you see this image, your whole brain is active. If you did like a EEG study or FNAIRS, or you'd see that pretty much everything will light up. And so I think neuroscience has a challenge in the sense that it's difficult to disentangle correlations. So does it light up because you're thinking, or does it light up because you need it for it? So correlation and causation is difficult. I think it's a difficult question for neuroscience. And I'm not a neuroscience expert, so apologies to all the neuroscientists if I've completely oversimplified here.
I am looking through the list of your publications, and I see one which the title is very interesting. But could you tell me what you found? The title is "Bilingual's Inhibitory Control and Attentional and you're talking about inhibitory control now. So, is there a difference between being monolingual and bilingual in your inhibitory control?
Yeah, so that is a very high contentious topic at the moment. So in the 90s and early 2000s, there was a lot of empirical evidence that shows that if you're bilingual, you have better inhibitory control, you're better able to switch between different tasks, you're better at planning, which is what we call executive functions. And now there is a large literature that questions some of these findings. And the answer is that it's not that simple. It very much depends on the type of task. It depends on the type of paradigm, and it depends. But one thing is for sure, there's no downside to being bilingual. So if anything, it has an advantage. But with regard to this publication, what is super interesting is that what we found is that bilinguals are actually better at switching ambiguous figures. And that makes sense, right? Because inhibitory control is required to switch. Bilinguals are better at inhibitory control. Therefore, they're more able, earlier, able to see the two interpretations than monolingual kids. So, being bilingual is a really good thing, if anything. Yeah, so that's the gist of the paper.
So, how drastic is this difference? Like, is it just a couple of weeks earlier that these bilingual kids can see the inhibitory things, or is it like years or so?
We found about half a year earlier. So they bilingual kids were matched in chronological age with the monolingual, and in cognitive ability they were matched, so they were all equal. And we found that by about half a year earlier you're able to switch. So there's if you do the age group of 5 year olds, you'll find that more of those bilingual kids are able to switch than the monolinguals. So it's not like that the monolinguals are not able to switch, it's just few of them and they just do it a little bit later. So because I have trilingual kids, so I have because I'm Austrian and my husband is French and we live in the UK, so they speak three languages. And then I get other parents who say, "Oh, they must be so confused. There's so much going on in the brain," and I'm like, "No, no, that's a good thing. There's no disadvantage."
It's funny because I was over in Scotland last month, and you meet anybody from mainland Europe, and everybody can speak at least three languages, and you're like, "What's going on?" Gro- growing up in New Zealand, where people are very die hard monolinguals. They-
It's not a disadvantage, and if you're a mom or dad or a caregiver of a bilingual child and your child starts speaking later, don't worry. That's but that's off topic. That's not linked to my research.
Still good to know. Can can we move slightly further on because I wanted to ask you about your false memory research. Um, so because that was the second thing which I described, could you please tell us what false memories are to begin with, and then we can ask a bit about your work in it.
Yeah, I mean, false memories are usually harmless and we have them all the time, right? So you think, oh, I saw this on TV, but actually it was your friend telling you something. Or you might remember, oh, I had a glass of Bordeaux with my dinner yesterday, but it was a Merlot. Or you thought you had sausage and mash on Sunday, but it was Yorkshire pudding. So these whatever you know these types of false memories, we have them all the time and they're very frequent, and we're very prone to having false memories, and usually we don't remember something completely different to what we experience. It's usually something that is linked to what we experienced that we just don't remember correctly, so that's a false memory. Because if you had sausage and mash and you remember it was Yorkshire pudding, that's a false memory. And they're benign and harmless. But obviously, in the legal arena, having a false memory has big consequences. So if you confuse the face of someone Or if you remember, he used a hammer instead of a, I don't know, screwdriver, um, or something like, oh, he was driving really fast when he was actually braking. Those are kind of severe false memories. So in this case, the false memory has strong consequences. And there are lots of cases where, in the legal arena, where eyewitnesses are where the only evidence comes from eyewitnesses. And so our memories are very, very fallible. And in the UK, and also in the States, there were a lot of high profile childcare cases about child abuse in the 80s. And that has triggered a lot of research into false memories in children. Again, where you have children being the only witnesses. And so there has been a lot of research happening since the 80s. And the general consensus was children's memory is not as good as adults' memories, and children remember less well, and they're more likely to have false memories. And the work I've been doing is actually that in some instances that's not the case. So give you an example, and I give you now, if you don't mind, I give you a little memory task. Don't write anything down. I give you a list of words. I want you to try and remember as many as you can. Okay?
Sounds good.
Um, right. Are you ready?
Yep.
Um, hot, snow, winter, ice, chilly, freeze. Okay? So now try and remember as many as you can. And I would like you to calculate now 120 minus 39 plus 8 minus 3. Okay?
Okay. 87, I think.
Amazing. Write down everything you remember.
Hmm.
So, Simone, I start with you. What do you remember?
What do I remember?
Yeah.
Uh, Ice, chili, and freeze,
Okay. And Sahia, what do you remember?
I think.
Yeah, I remember those three too. Those are the three I've written down. But I have a feeling you said. I have a feeling that your voice cut out in the middle as well when you were lining those up. Did it happen to you as well, uh, Simona?
I think so, possibly.
So this is what is this called, the Dees Rödiger McDermott paradigm. These are the scientists who developed that paradigm. And what happens, so you have freeze, chili, and ice. And what you have is these are words that are semantically related to the word cold. And cold is not presented. And what happens, or I never said cold. And what happens is that many people will falsely remember cold because cold is semantically related to those words. And when we remember things, what we do is we make associations, some of which are false. And what we find is that in that instance, adults have actually more false memories than children.
Oh,
So it's not true to say that adults have a better memory or they remember more or they remember better. it actually depends. So in this case, um, when you present associative information, adults have more false memories than children. And when you overlay the true and the false memories, you see actually a net decrease in accuracy with age. So critics would say, well, that's just a very specific paradigm that doesn't tell us much about memory in the real world. I would argue, well, it does tell us a lot about our, our cognitive processes and how we remember things, and that we're very susceptible to having false memories, because what we do as adults, we form associations, we make these associations automatically, and some of them are false. So I would say it tells us actually a lot about, the cognitive processes and how we remember things.
Is it a little bit because I feel the older you are, the more vocabulary you have? So if you know more similar words, you're more likely to make those associations. And if you're a kid, you don't know as many words, so you're less likely to.
No, because those no, it's about that you as an adult, you're more likely to make associations, not because you know the word. So the kid, because that's been done with, it's been controlled for using words that kids are very familiar as well. So it's not the familiarity with the word in itself, it's the ability and the automaticity of making associations. And as we get older, we do this more. We have more knowledge, obviously, so we make those connections easier and faster. And that's the thing that drives false memories. um, and I think what is interesting is that that also means that adults, it's way harder to prevent them from happening in adults. So if you're distracted, um, you might have them nonetheless. Whereas if you're distracted as a child, you're much less likely to have a false memory. So if you think of an airport and it's super busy and there are lots of things going on, and you witness an event and you're distracted, you might be less influenced by the distraction than a child is. So it's not correct to say that adults have better memory, are the better witnesses. It's just, it depends.
You mentioned at the beginning that most false memories are benign. So, is there a reason for why we have them? In the sense, is there a evolutionary reason for why we have so many false memories?
I guess it's got to do with that our memory isn't a copy machine or a video recorder, right? Our memory is what we call reconstructive. So you're not replaying the same scene that you've seen or the same conversation, you reconstruct. So it's like, so your memory does something when you try and remember. So it's not a one-to-one mapping between what you've seen and then what you report or what you remember. And so, and this false memories are just a byproduct of this reconstruction. So they're not, we would argue, they're not any different memory processes. They're just a reconstructive process that is just wrong. Some stuff you reconstruct is just wrong. um, and it's just being aware that they happen to us very frequently and that they're usually benign. But obviously, in cases of where eyewitnesses are the only evidence, um, it's good to know how good or bad our memory is and under which circumstances we are most likely or least likely able to remember things. And children for that matter.
Hmm. That's really interesting. It sounds like there's kind of an overlap between the visual stuff that you do and the false memory stuff. Is it because of like they work on the same sort of principles to do with perception and things?
So my so that's an interesting thing. So my memory research developed out of a postdoc I did, and so that's how it came about. And what is interesting with the memory research is memory for pictures, for example, or for visual information is helps us. So anything visual is quite good for us and for our memory accuracy. And if we see something, we tend to remember it better than if we just hear something. So, and for visual information, adults are actually much better in remembering than kids, and we're less likely to have false memories um, because you can use the distinctiveness of the information as a kind of yes, I remember that yeah, I've seen that before. So so but usually when you remember stuff, you don't just have the visual or you don't just have the auditory, you have a mixture of the two, and that's where it gets a bit complicated. So that's led to this research that I'm doing now on false memories for fake news. So with my PhD student Ted Webster, he's looking at false memories for fake news. So fake news that he constructed that have never been out. So the news that have never been out there, and he's looking at whether people remember these fake news and what their confidence is about, and that's I think is a very interesting line of research where you have the visual and the auditory and that combined, and shows that yeah, you're more likely to remember things that are in line with your beliefs and or more likely to falsely remember things that are more aligned with your beliefs. So and fact checking is moderately or not very effective.
That sounds like a very interesting research project. Um, do do you need to create your own fake news? Can't you find information which is already out there, or is
Well,
there a
then it wouldn't
reason?
be fake. So you need to make sure that it is really fake. It wouldn't be fake, right? If it's already out there, because we're not talking when we say fake news, we're not talking about news that is correct, because that's another. So we're not using obvious fake news that is already out there. What we are interested in is, do people develop a memory for news that have never, where we know it's fake for sure, that they've never seen before? Because you could remember a fake news article that was previously presented, but it was just one that was, so it wouldn't allow you to identify whether you're susceptible to fake news. Because if it was even though the content is fake, it was previously presented. So if you remember it, it's correct because it was there before.
Hmm. Um, do you have fears if your participants take the fake news which you provide into the real world?
Yes, so we are very concerned about that. So it's really important to debrief participants. And so one of you need to have you need to make sure that they get debriefed. So one of the things that is really important is to say to participants, you can withdraw at any time. If you close the browser, you're not gonna get debriefed. So you might, if you want to stop the experiment at any time, you can do that, but go to the debrief so that you know what the experiment is about. And then in the debrief, we make sure that we tell them exactly which news articles were fake and that they were constructed by the experimenter, and we give them sources of the real correct content. So debriefing is extremely important in that type of research. I should say that our stimuli are not are all controlled for emotionality and valence, and so we are using political news. So we do not use extremely disturbing material for ethical reasons. So, for example, which people find quite humorous and remember quite well, one of the fake news is that, for example, is that Joe Biden forgot the anthem, the lyrics of of the American anthem at a NFL game or something like that, which seems plausible.
I was about to
And
say.
or that Donald Trump spent millions of pounds in mascots during the Thanksgiving parade.
Also plausible.
Yeah, plausible but fake.
So then, how do you are you measuring their recall? Are these news articles just kind of written articles, or is there some video to go along with it? How?
It's a very simple experiment. So it's a picture of a news item and a text underneath with one or two sentences. And then participants are asked, do you remember this? Yes or no, or believe it might have happened. And then what's your confidence in your memory? And so half of the news items are, well, the majority is true. So true in the sense that there were real news reports. They might not be completely true, but they've been presented before. And in between of those, there are some that are fake, that are generated by the researcher. And then we look at the effects of fact checking, um, cortical activation at the moment, bullshit receptivity, and the link to your political beliefs. So this is now quite well established that if something aligns with your political beliefs, you're more likely to falsely remember it. But you might be yeah, so political bias. So the only way to prevent false memories or to be falling prey to fake news is to just think twice, to have a bit of reflection when you read news, and that seems to be the only effective way of, yeah, of not falling prey to fake news.
Are there kind of like specific things we should be thinking twice about? Like, just from the perspective of a media student, the whole falling prey to fake news is very interesting. But has there been any sort of identified things that when we look out for kind of help us identify false memories?
It's pretty hard to identify false fake news, so it's really hard to distinguish them from real ones, especially if they align with our political beliefs. But um, but if you know about something and you think, oh, that doesn't sound right, or I'm not sure, and you can look at the source where this comes from, and you might want to inquire more. So there isn't a good way of preventing you to falling prey for fake news, because it's very hard to tell which ones are fake. So um so um political figures say we should train people to detect fake news, and scientists would say, well, that's a lost cause because we're pretty bad at detecting them in the first place. It's better you tell people to a bit more inquisitive and question things and don't take out up things automatically.
It's really interesting also that you said fact checkers don't work. Was that like as in the little things at the bottom of the Instagram posts or
Yeah, so we haven't analyzed the data fully, and there is a lot of literature out there already. But what we tend to find is that just they work because they're a distraction. So they work because you're not taking in the news as much as if there wasn't a box there, but they're no different from a distraction. But I don't want to say too much because we haven't fully analyzed the data. So it looks like to this date that they work because they're distraction, but not because they're telling you about the facts. So you remember things worse in the first place because you're distracted.
That's a very interesting perspective on it. I know the first years at the moment are doing an assignment. Sorry, not the first years, the second years at the moment are doing an assignment over here where they're trying to develop scales to measure misinformation. Um,
Ooh,
so as a as a core as a class project, not class, but like
brilliant.
yeah, so they're probably going to listen to this and be like, oh, there's actually nothing we can do about it. The whole thing's so we need to be careful.
Pull it all off.
but but can I ask then, because you said you give like a news title and images. Do people associate things more? Are images more capturing, or are the news titles more capturing? I guess that's also a marketing slash media question, isn't it? Just as much. What's more memorable in context of fake news, but in context of, I guess, perception as well?
It's always the visual that is more memorable. So visual information is way more memorable. But obviously you need, if you just have a picture, it's ambiguous. So that's why you need the, if you know, because if you just see a picture of Donald Trump and a teddy bear, you don't know what the news is here. So you need some text to go underneath. Um, but that's obviously not, I mean, and that is as close as real news work, right? You have an image, you have a hook. I mean, I'm talking to a media expert here, but that's what we feel, that how news work, where you not first read the whole article, you see an image and the tagline, and that's what draws you in.
Yep. Cool. Let's talk about the final thing now, which I mentioned, because we first mentioned false, ambiguous images. Then we talked about false memories. The last thing which you say is perceiving things which aren't even there. I know that's connected a little bit to false memories, but that was the last thing which I said in your introduction. So can you talk about those things? So, what are they? What are the things we perceive which we don't actually even see, or we see, quote unquote?
Yeah, thank you. And I love it that you did it in that order, because so that's exactly the order in which I've done my research. So I started off with visual ambiguity and found that mental imagery is very important. And then I worked on false memories, and there's also a big literature that finds that mental imagery is quite important in false memories. And then I got my own grant to look at the development of mental imagery. So that's exactly how it unfolded. So imagery is at the is in between memory and visual perception, because it's like seeing something in your mind that isn't in front of you. So say, for example, if you guys think of your living room at home, and you got a mental image of your living room, and then you might want to think about how would it look like if I put the sofa in a different spot and rearrange the table, or I don't know if you have a TV in your living room, and if I rearranged the furniture a little bit, how would that look like? Or how would it look like if I bought this picture, and where would I put it in the living room? So in all those instances, you're using mental imagery. And so, and you're not only able to have a picture of your mental image of your living room, but you can actually picture it how it would look like if you rearrange the furniture. You can do that. And so that's, I think, pretty cool. And you need that on a day-to-day basis when parking a car. You need to use imagery. You need to figure out, will the car fit in the spot? I'm quite bad at this. I'm always very optimistic. It will fit, and then, oh no, it doesn't. But just to say that we use mental imagery daily, or if I'm planning the route to work, which route am I going to take? I mean, usually we tend to take the same one, but maybe sometimes there is a building site or we need to take a different. So in all those instances, or where did I leave the key? And you picture the room and you go back. So long story short, imagery you use daily, it's a very important process. But how do you measure it? It's in your head. It's like it's almost impossible to measure, you'd think, right? Because and so scientists in the 70s and the 80s had this debate, do we actually have pictures in our head or is there no particular picture? And there was a lot of back and forth between Steve Koslin and Palishin, and the Palishin took more of a philosophical approach, but there was a lot of back and forth. And again, we've used the developmental approach to see how imagery develops. So one of the things that we do in imagery is mental rotation. That's an imagery ability. So mental rotation, thinking about how would your sofa look like if I moved it to the other spot. That is mental rotation in a sense. Or if you play Tetris, you're using mental rotation. I don't know, is Tetris still the thing it was in the olden days, in my days?
I, I still play Tetris. I don't know about.
Okay, good.
But then,
Phew. So yeah, you're using mental rotation there. And interestingly, kids before the age of 5 find it quite hard to do mental rotation. It's quite difficult. So when they do puzzles, they have to really physically move the puzzle pieces, for example, because it's quite hard to do in your head. So what we find is that if we have to do mental rotation, that the longer the rotation angle, and we have to judge whether something is the same or different, the longer it takes us to make those judgments. And it's linear, it's correlated with the angle. So 0 degrees, quite quick, 30 degrees takes longer, 60 degrees, and so forth. And so there's what you find is a nice linear curve like that goes up. So the more the rotation angle, the longer it takes you. It's called a linear relation between and so that is taken as evidence that we actually do have pictures in our head, because why would it take us longer to say whether two things are the same or different if as a function of rotation angle, right? Then you wouldn't have this linear increase if you didn't have to do it in your head as a mental image. So that's one good evidence. And so we've been looking at whether kids' mental images are depictive in format, and or whether that's something that once your imagery ability develops, you eventually have this picture in your head. And we find that from when we have imagery, we already have pictures in our head. So what we find is that already children, when they're able to do imagery, they really have pictures in our head. Another example of how to measure it is called the famous island task. Is where you study an island and there are different landmarks on the island, like a palm tree, a lake, a lighthouse, and they're different distances apart. And you make sure that they remember where these landmarks are, and then you ask them, now I want you to close your eyes, and we do it in a game form. So there's Percy, the parrot who flies or he walks from one one place to the other and close your eyes. And now imagine Percy walking from the volcano to the lighthouse, or from the lighthouse to the lake, or whatever. And they're all at different distances apart. And then they're asked, say stop when Percy's there. And what we find is, just like with rotation, that there's a linear relationship between the distance and the time it takes, which suggests that you really have formed a mental image, an image of the island, the distances of the landmarks. And kids already have these depictive mental images. And so that's the third line of research. It's obviously quite hard to do because it's all relying on what people report. And was quite difficult research to do.
That's really interesting. So what are the current findings which you have from that research? Are you, like you said, you have a PhD student doing work on false memories? Do you have any students doing work on that now?
So I still have a lot of data that I haven't written up, and I don't want to say too much because I haven't published it. But we've been looking at mental images for visual illusions and stuff like that. So where you're affected by um, by what you know, by yeah. So at the moment, I have no student who is doing this type of research, and it's, as I said, it's very hard to do, and it's very blue sky research. Thinking about what picture do we have in our head when we have a mental image of our. Do we have a picture in our head if we have a mental image of our living room? So it's obviously but it's, as I said, it's very important for day-to-day life. So
So then if you were given all the money in the world to do your next research project, what would you like to do? What would be the next uh, steps?
if I had unlimited funding and unlimited access, I would do a mega study of all these three research strands, um, in all the schools of Scotland, test all the children of Scotland, and look at the relationship between those abilities, and look at the course over the primary school age. So if I were given unlimited funding, I'd do a mega study bringing all these lines of research together. But yeah, so it's unlikely that that's gonna. I think what I want to say is that I think fundamental science is still really, really, really important, and the funding landscape is more and more geared towards policies, and I think I would like to advocate that fundamental research is still extremely important, and we should not forget about that.
I feel stuff like your false memories would probably be considered both fundamental as well as policy driven, because I feel that's something which would be very important, as you said, in court cases, for example,
Mhm.
the importance of it. Uh, with all that, do you reckon using memories or using witness testimony is an issue in most cases?
No, it's absolutely not. It's as long as you're aware of interviewing techniques, as long as you're aware of how memory works. So there was a big outcry of Elizabeth Loftus testifying in the Ghislaine Maxwell case, and everything she says was not outrageous at all about how we know what memory works, and actually it's been used by the defense as that she's actually questioning the testimony and the memory of the victims, but actually all she said is that memory is fallible, which is true, and that we are unlikely to falsely remember central details of an event. So if you look at that, actually, she's not at all questioned the accounts of the victims. And so no, I think it's just sad that usually um, we are not we are not taking into consideration what we know about memory. So to give you a recent example, there was a footballer, Ryan Giggs, who was accused um, of of assaulting his girlfriend, and the only witness was him and his girlfriend and his sister, and the jury couldn't reach a verdict, and there was a real retrial a year later, which is obviously a disaster for memory. So there's not a chance that a year later you'll have a more accurate report of what has happened. So unfortunately, in real life, what we know about memory isn't really still not very much applied in the courtroom.
Simone, do you have anything to say? Any more questions?
Not particularly. This has been really
Cool.
interesting to hear about. I feel like I'm absorbing it and getting
Yeah, no,
more in my brain.
yeah. The other reason I asked that was because we've been recording for around an hour, and usually this is the time because all research stuff is heavy. So I think if we keep going on for longer as well, there's you get to the point where we're probably doing a disservice to everyone. Um,
I feel like my brain is slowly frying in like a good way, in a way that I'm going to wake up tomorrow with more memories. It's just at the moment I'm like, whoa.
yeah. In light of that, should we kind of wind down? Should we do like the last bit, which we do? So, Simone, I've sent to you the other half of the questions which we ask. So, Marina, the way it goes is we will ask you some questions. They're very general, and you just answer them back to us.
Okay. Summer or winter?
Summer.
Movies or TV shows?
TV shows.
Cats or dogs?
Cats.
Which superpower would you like to have?
I would love to fly.
What's your favorite food / cuisine?
Italian and spaghetti.
What's your least favorite type of music?
Techno.
If you could live anywhere in the world, where would that be?
Having lived in a lot of places, pretty happy in Scotland right now.
What is the worst thing you've paid money for?
Oh my god, that's really hard. The worst thing. I don't know. Probably some clothes that doesn't fit. I buy clothes all the time that doesn't fit.
If you were not doing this, what would you be doing?
I would do my climate action work. I'm in a local climate action network.
All right. The very last question we ask is if you could give us, the listeners, everyone, one piece of advice, what would it be?
Um, just enjoy what you're doing, and you're not gonna lie on your deathbed thinking, "I wish that worked more." So that's the piece of advice.
I think that's very good advice.
Yeah,
All
pretty solid.
right. Well, thank you so much for joining us. Thanks, Simon, as well. Hopefully, you can come back on more. Hope you enjoyed your time.
Yeah, it's been pretty cool. Like I said, brain expanding.
And thanks, Marina. Hopefully, next time you can give us more results, which you didn't want to tell us this time.
Yeah. Thank you so much, Sahir, for inviting me. That was fun, actually. I was a bit nervous, but that was fun.
That's good. Now you can tell everybody else in the department to also come join us because they've been ignoring my emails.
Who? Tell me who. I'll whip them into shape.
I'm not going to name names here. I'll send you the list on email. Thanks so much again. Thanks everybody for listening, and see you guys next time. Okay, bye.
Thank you. Bye.
Bye.